The audio and radio management system is composed of the radio communication and radio navigation management system, passenger address and communication interphone system, the audio integration system, and the static discharging system. The radio communication system enables the cockpit crew to talk air-to-air or air-to-ground via two very high-frequency radios. The interphone system enables communication among the crew and to ramp personnel. The passenger address system provides a means for the cockpit and cabin crews to make live announcements and to play pre-recorded announcements via cabin loudspeakers. Static discharging has two purposes: to prevent the dangerous effects of lightning discharge on the airframe and to decrease the interference static electricity causes to radio communications. Communication-related equipment in the aircraft includes the cockpit voice recorder, CVR, the flight data recorder, FDR, and the emergency locator transmitter, ELT. The audio and radio management system, ARMS, uses two audio and radio control display units, ARCDU-1 and ARCDU-2, to supply the flight crew and observer with individual control of the communication radios, navigation receivers, audio signals, interphone between pilot, co-pilot, observer, and ground crew, and the passenger address and communication interphone system, PACIS. Several line replaceable units are in the cockpit for the pilot, the co-pilot, and an observer. There are boom sets, handheld microphones, and mask mics for transmitting. For receiving, there are headphones and loudspeakers. To activate transmission via the microphones, there are push-to-talk, hot mic switches on each yoke, and one push-to-talk switch on the nose wheel steering control. 3 jack panels are located in the cockpit. The observer's jack panel has an integrated audio control panel and a transmit interphone toggle switch. The passenger address, PA system, allows announcements to be made to passengers either by pilots on the flight deck or the cabin crew members at their stations. The announcements are heard through speakers located in the cabin and in the lavatories. The use of the PA system is prioritized. The announcements from the flight deck have first priority and override all others. The announcements from the forward flight attendant station override the aft flight attendant station and the passenger entertainment system. The passenger address, or PA, control system consists of the forward attendant handset and remote control panel, the aft attendant handset, and the audio and radio control display units. The audio and radio control display units, the forward attendant handset with its remote control panel, and the aft attendant handset control the PA announcements. To make a passenger address from the flight deck, the rotary microphone selector on the audio and radio control display unit is set to the PA position, and the PA key is pushed to start the PA mode. A green annunciation comes on in the PA key of both audio and radio control display units. The passenger address key annunciation on the forward attendant control panel and on the aft attendant handset cradle comes on, and the green annunciations on 3 cabin advisory light panels illuminate. When a push-to-talk selection is made by a pilot speaking into a boom, mask, or hand microphone, a PA announcement through the cabin speaker network is heard. The PA key is pushed again, or the rotary microphone selector is moved from the PA position to cancel the PA mode. When the chime key is pushed, the high-low chime is sounded in the cabin. In the communication interphone mode, the audio and radio control display units, the forward attendant handset with its remote control panel, and aft attendant handset are used to make a cabin interphone mode selection. When the rotary microphone selector on the audio and radio control display units is set to the PA position and the call or emergency key is pushed, an interphone mode is started. The call key is pushed for normal operation and the emergency key for the emergency mode. Annunciations on the audio and radio control display units, the forward attendant remote control panel, and aft attendant handset come on in green to show normal operation, and flashing amber lights come on to show emergency operation. A two-tone high-low chime is sounded, and a red annunciation light comes steadily on in the cabin advisory light panels for a normal call and flashes for an emergency call. A flight attendant call selection will cause the high-low chime to sound in the cabin only. An emergency selection will cause the high-low chime to sound in the flight compartment and in the cabin. The pilots push the PTT switch to speak to the flight attendants. The flight attendants speak and listen to the pilots at the same time from the two cabin positions. When the handset is removed and the call or emergency key on the forward or aft flight attendant's handset is pushed, an interphone mode is started. The same green or flashing amber lights as with the audio and radio control display units selection come on to show normal or emergency operation. A red annunciation light also comes on in the cabin advisory light panels. A two-tone high-low chime also sounds when a normal or emergency cabin interphone selection is made. The flight attendants can also call each other. When the forward or aft attendant key on one flight attendant's handset is pushed, a high-low chime sounds in the cabin compartment and a call is made to the other flight attendant. Note, there is no indication in the flight compartment. The passengers can call the flight attendants from individual seat positions via the passenger service units and from an attendant call switch in the lavatory. When activated via the passenger service units, a one-tone high chime sounds in the cabin, and a white annunciation light in the advisory panels, and a red flight attendant call light indicator near the passenger seat comes on. When activated from the lavatory, an amber light in the advisory panels comes on and a one-tone high chime sounds in the cabin. Air-to-air and air-to-ground radio communication is established by the flight crew via 2 or optionally 3 VHF COM modules. They are located on the top shelf of the avionics rack. 2 audio and radio control display units, the standby controller for VHF-1 transceiver, and the FMS multifunctional control display unit provide the controls for channel selection. The system has an automatic transmit timeout to prevent blockage of a communication channel if a mic, boom, push-to-talk button is for any reason stuck active. All communications via the audio control panels are recorded in the cockpit voice recorder. The audio and radio control display units provide the primary means of tuning the radios. By selecting the rotary switch to the on position, the pilot has access to radio page 1 or 2 via the page 1 or 2 buttons. A minimum of 2 steps are required to change the active frequency. The side key adjacent to the VHF communication display area is pushed to highlight the preset frequency and must be pushed again to make the preset frequency active. The frequency that was active now becomes the new preset frequency. To change the preset frequency, the side key must be pushed. The preset frequency in the display area highlights. The preset frequency can now be changed by turning the tune double rotary knobs. The side key is pushed again to set the new active frequency. The frequency that was active now becomes the new preset frequency. The channel key is pushed to set the channel memory mode from 8 preset frequencies using a channel memory selection. A channel memory annunciator comes into view below the active frequency indication. In addition, the channel memory number is shown adjacent to the preset frequency. The side key is pushed to change the preset frequency. When the tune double rotary knobs are turned, the channel memory number shown adjacent to the preset frequency changes. The programmed frequency for the channel memory is shown in place of the preset value as black characters on cyan. The VHF communication side key is pushed again to validate the channel memory selection. Pushing the communication side key twice causes the preset frequency to replace the active frequency. The communication particular page comes into view when first the communication side key is pushed, and then the expand key on the keyboard is pressed. The particular page can be used to change the VHF communication receiver, VHF COM1 or VHF COM2 modes, channel programming, and to test the system. To access the channel programming mode, the side key adjacent to the channel's legend is pushed. The channel presets are labeled as channel 1 through channel 8 in white characters. When the side key related to the channel being changed is pushed, the current frequency value changes to black characters on a cyan background. The 2 tune concentric knobs must be turned to change the frequency. The side key is pushed again to validate the new frequency. The channel window shows the new frequency in cyan characters on a black display. The VHF-1 or VHF-2 potentiometer push-button switches control the audio parameters to on or off and are used to adjust the volume level. The top part of the potentiometer is pushed to turn the specific audio signal to the headphone on or off. When the speaker push-button potentiometer switch is pushed, the VHF communication audio is routed to the 2 flight compartment speakers and is indicated by a loudspeaker graphic in the interphone window. The communication receiver display area shows the volume level as a vertical bar graph. The height of the bar graph shows the volume selection level. When the audio is set to off, the bar graph is shown in white. A standby control panel is used to control the VHF-1 frequency selections when the 2 audio and radio control display units malfunction. The standby controller contains an on, off, test selector switch, a frequency rotary selector, an active frequency indicator, a preset frequency indication, and a frequency transfer push button. The on-off test rotary switch must be set to the on position to energize the standby control panel. This selection is indicated by a standby control message in the active frequency area of the audio and radio control display unit VHF-1 display area. The 2 frequency rotary selectors are turned to change the frequency. The outer selector changes the whole megahertz frequencies, and the inner selector changes the fractional megahertz frequencies. The on-off test rotary switch is pushed to start the VHF communication test mode. The audio module automatic squelch circuit is disabled to let the VHF communication receiver noise be heard. This makes sure that the receiver is operational. The frequency transfer push button switch is pushed for 2 seconds to toggle the active and standby frequencies. If the indication malfunctions, the frequency transfer push-button switch must be pushed for 7 seconds or more to tune the VHF transceiver to 121.5 MHz. The interphone system is for crew-to-crew communication and includes the flight crew interphone, the service interphone, and the passenger address communication interphone system, PACIS. The flight crew interphone is for flight deck communication and is controlled via the audio and radio control display units and the observer's audio control panel. The interphone system includes the pilot, co-pilot, observer, forward ground crew jack at the left-hand nose, an aft ground crew jack on the refuel-defuel panel in the right-hand nacelle, and one in the tail of the aircraft located near the cockpit voice recorder. Interphone communication from any of these 3 stations first requires that the operator select Interphone on the 2 audio and radio control display units, microphone interphone selector. Pressing any transmit, push-to-talk, interphone, or hand microphone push-to-talk switch keys the interphone. If interphone is not selected on the microphone interphone rotary selector, then it is possible to have interphone communication only by setting the push-to-talk interphone switch on either control column to interphone. For the co-pilot, there is an interphone transmit switch on the co-pilot side panel which can be set to interphone. Interphone audio can be received and its volume adjusted at each station by pressing and rotating the service interphone volume control. The forward ground crew station and the aft ground crew station receive interphone audio at all times. When the ground crew headset microphone is plugged into the jack at the left nose, the ground crew forward advisory light, located on the pilot's side console, comes on. When the ground crew headset microphone is plugged into the jack labeled Ground Crew Jack on the refuel-defuel panel, the ground crew aft advisory light comes on. The forward and aft advisory lights alert the flight crew that interphone communication may be made with the respective ground crew station. If either the pilot's or co-pilot's audio system fails, the affected crew member can select the normal emergency switch on the audio and radio control display unit to the emergency position to connect the headphone and speakers directly to the related VHF communication transceiver and VHF navigation receiver. The audio is set to a predetermined level and cannot be controlled by the potentiometer push-button switches. A red fail message is shown in the interphone display area to show that the remote control audio unit is not being used. The passenger address and communication interphone system allows pilots and cabin crew to conduct private voice communication between the flight deck and cabin crew member stations and performs visual and oral notification of both normal and emergency calls. If the primary aircraft power fails, the emergency light batteries energize a relay that switches the passenger address and communication interphone system power from left essential bus to the battery power bus when the emergency lights are on. In this mode, even if the engines and auxiliary power have stopped and no external power sources are connected, the pilot and the 2 flight attendants can make passenger address announcements when the primary electrical power source is not available. On aircraft equipped with the Passenger Entertainment System, PES, the system supplies different programmed voice passenger addresses, PA, and music to the Passenger Address and Cabin Interphone System, PACIS, and Audio Integrating System, AIS. The Passenger Entertainment System has the following components: Digital Passenger Announcement System, DPAS unit. PCM-CIA memory card. The Digital Passenger Announcement System, DPAS, unit has 15 languages. Only 4 can be programmed at a given time. The DPAS unit is attached to the forward attendant station above the wardrobe shelf at station points X12.69, Y-20.06, and Z168.6 with 4 fasteners, and the unit contains all electronic circuitry necessary for its operation. The system is operated from controls located on the DPAS unit front panel. The PCM-CIA memory card is inserted in a slot located on the left side of the DPAS unit. It must be installed for the system to operate. Inserting a newly programmed card will change the passenger address and music selections. The PCM-CIA memory card has 20 megabytes of memory. It can be programmed for a maximum of 43 minutes 41 seconds of passenger addresses and 87 minutes 22 seconds of music. The Active Noise and Vibration Control System, ANVC, installed in the passenger compartment is designed to decrease the periodic noise and vibration caused by the aircraft propellers. The ANVC generates a secondary noise and vibration field in the passenger cabin, which cancels the propeller-induced original noise and vibration, resulting in lower noise and vibration levels. The ANVC system includes the following components: the Active Noise Control Unit, the Active Tuned Vibration Attenuators, the Power Amplifiers, the microphones, and the controls located on the Flight Attendant Master Display Panel. The ANVS controls are located on the Master Display Panel and consist of 2 switches and indicating lights. The 2 switches are an on-off switch and a pause switch that puts the system in standby mode or returns the system to active mode. The lights off and pause indicate if the system is off or in standby. The ANVC operates automatically and is continuously self-monitoring. Failure or partial failure will cause advisory lights to come on. The radio management system has 2 audio and radio control display units, which are the crew interface for the communication system to tune, display, and control the operational modes of the radio communication and radio navigation systems. The units also control the operation of the passenger address and communication interphone system and control the audio selection to the pilot's headphones and flight deck speakers. The radio management system monitors the radio comm and the radio nav system and displays a message in the event a malfunction within the system is detected. When the audio and radio control display unit rotary microphone selector switch is set to the service interphone position, all push-to-talk selections provide interphone communications to all stations. When the ground crew headset is plugged into a service interphone jack, the ground crew advisory light on the pilot side console comes on with an applicable forward or aft indication to indicate a service interphone connection. The lower part of the audio and radio control display unit front panel contains the audio potentiometer push-button switches, a rotary microphone selector switch, and toggle switches to operate the audio integration system. The normal emergency toggle switch is set to the normal position to independently control the audio outputs using the potentiometer push-button switches. The normal emergency toggle switch is set to emergency position to connect the headset and microphones directly to the related VHF communication transceiver. The audio is set to a predetermined level and cannot be controlled by the potentiometer push-button switches. To indicate the selection, A red message is shown in the interphone display area to show that the remote control audio unit is not being used. The boom mask toggle switch is set to the boom position to supply headset boom microphone audio to the audio integrated system. It is set to the mask position to supply oxygen mask microphone audio. The hot microphone toggle switch is set to the hot mic position to give a continuous selection of the flight crew interphone function. The potentiometer push-button switch consists of two parts. The top part of the potentiometer push-button switch is pushed to route that system's audio to the related headphone and must be turned to adjust the audio level. The display area shows the volume level as a vertical bar graph whose height represents the volume level. When the audio is set to off, the bar graph is shown in white, and when it is set to on, it changes to green. The speaker push-button potentiometer switch is pushed to route the headphone audio selection to its related flight compartment speaker. The display area shows a speaker graphic when the speaker is selected. The rotary microphone transmitter selector switch is turned to make a radio transmitter selection, followed by a push-to-talk selection to transmit. A green transmitter annunciator in the related radio system's display area is used to show the push-to-talk selection. The rotary microphone selector switch is set to the serve, INT, or PA position, followed by a push-to-talk selection to make an interphone transmission or a passenger address. A green INT transmitter or PA transmitter annunciator in the interphone display area is used to show the push-to-talk selection. The audio integration system controls on the observer's audio control panel are the transmitter keys, the interphone radio toggle switch, and the headphone audio potentiometers. A transmitter key must be pushed to make a radio transmitter or flight crew interphone selection. The interphone radio toggle switch is set to the radio position to make a transceiver push-to-talk selection and to interphone to make an interphone system push-to-talk selection. The switch lever is spring-loaded to the radio position and is latched in the off and interphone positions. The headphone audio potentiometers control the audio volume of the systems. The audio is off when a potentiometer is selected to the full counterclockwise position. The observer's audio jack box contains the boom mask toggle switch, the VOR MLS toggle switch, and a headphone and microphone plug. The boom mask toggle switch is set to the boom position to supply headset boom microphone audio to the audio integration system. It is set to the mask position to supply oxygen mask microphone audio. The VOR MLS toggle switch is set to the VOR position to let the observer's audio control panel control the audio from the VHF navigation receiver that is selected on the flight guidance control panel. It is set to the MLS position to let the observer's audio control panel control the audio from the MLS receiver that is selected on the flight guidance control panel. The audio integration system uses the audio and radio control display units and the observer's audio control panel to control the remote control audio unit, which in turn controls the observer's audio control panel, the flight deck speakers, the hand microphones, the cockpit jack boxes, the ground crew jack boxes, pilot and co-pilot's push-to-talk switches, the pilot and co-pilot's transmit interphone switches, and the cockpit voice recorder. The static discharging system consists of dischargers located on the aircraft trailing edges, which dissipate electrostatic charges from the aircraft structure to the surrounding air. This system is used to minimize radio interference caused by these charges. There are 5 static dischargers on each of the aileron trailing edges, 3 on each elevator trailing edge, and 5 on the rudder trailing edge. Airfoil tip dischargers, which are slightly different from the ones on the trailing edges, are installed 1 each on the wingtip and 1 each on the elevator tip. In total, there are 25 static dischargers. The solid-state cockpit voice recorder SSCVR system provides a continuous recording of all the flight crew communications, cockpit conversations, and passenger address audio during the time the aircraft electrical system is powered. The system recordings provide an essential investigation aid should the aircraft be involved in an accident. The system consists of 3 main components: the solid-state cockpit voice recorder itself, located in the tail cone for maximum chance of survival of the unit in the event of a crash, an underwater locating device attached to the voice recorder, and the cockpit voice recorder monitor panel located in the flight compartment. Also, an acceleration inertia switch located in the lower fuselage is responsible for discontinuing the cockpit voice recorder recording in case of an accident. The solid-state cockpit voice recorder is housed in an armored enclosure to ensure that the unit will survive a crash impact. To make it easier to find the box in poor visibility, it is painted bright orange and has reflective tape affixed to it. On the front panel, there is a bracket to hold the underwater locating device. The solid-state cockpit voice recorder system has 4 channel inputs. Channel 1, observer and passenger address audio. Channel 2, co-pilot's audio. Channel 3, pilot's audio. And Channel 4, the area microphone audio. The recorder automatically erases as it records, so that only the last 2 hours of recording are retained. To test the cockpit voice recorder system, a headset has to be plugged into the headset jack on the microphone monitor unit. When the test push button on the microphone monitor unit is pushed, an 800 Hz tone is applied for 2 seconds at the audio monitor headphone output jack, and the red status indication turns on for 1 second when the test is successful. Whenever the aircraft is on ground and the park brake is set, all audio can be erased via the Erase button. When pressed, all audio data is erased within 5 seconds. This is verified by a 400 Hz tone in the headphone jack. The underwater locating device, mounted on a bracket fastened to the front cover of the solid-state cockpit voice recorder, has its own power source. It is activated automatically upon immersion in water at all depths from 0.5 to 20,000 feet to assist in locating a submerged cockpit voice recorder.